Dear students, welcome to s.mathguru classes. Now today we start some problems if right hand side algebraic and trigonometry given. Trigonometry only sine and cos given. So if we have this type of problem, how to solve this type of problem? So solution start. We write this one d square plus 4 into y equal to x sin x. Then auxiliary equation equal to m square plus 4 equal to 0. M square equal to minus 4. M equal to plus minus root over minus 4. M equal to plus minus twice I. This is roots are complex. Therefore, complementary function equal to a cos twice x b sin twice x. We get this. Now particular integral equal to right hand side divided by this d square plus 4. This is the particular integral, but here we have algebraic and trigonometry only sign. So if we get this type of problem, this is difficult to solve. Now I taking another help. The another help is this is sin x. Now we know e to the power ix equal to cos x plus I sin x. This is in case of complex trigonometry, we know e to the power ix equal to cos x plus sin ix. This is called real part, this is imaginary part. So we can write real part is cos x, imaginary part of this. So if we write real part of e to the power ix, this will be cos x, real part, real short form, real part of, and imaginary part of this is sin x. Sin x is imaginary part and cos x is real part. But in our problem, this one given sin x. Sin x given, we want to write, we remove this sign, we write imaginary part of ix. That means obviously sin x. So this can be written as imaginary part of x cos x plus I sin x divided by d square plus 4. So cos x plus I sin x, imaginary part means sin x. We remove this and we get cos x plus I sin x, but here I have written imaginary part of this. Imaginary part of this means sin x. We get this one, x into sin x, we get this. Now this can be written as imaginary part of x e to the power ix d square plus 4. E to the power ix means cos x plus I sin x. Cos x plus I sin x, we write e to the power ix. Now what we get? Exponential and algebraic we get. So imaginary part of e to the power ix taking outside. If we taking this is outside, then d equal to putting d plus I. D equal to d plus I we putting. Now this will be imaginary part of e to the power ix x by this is d square plus twice di plus I square plus 4. This one imaginary part of e to the power ix x by d square plus twice di, this is minus 1 plus 4 imaginary part of e to the power ix x by d square plus twice di plus 3. We get this one. So this is imaginary part of e to the power ix x by, from this taking 3 common, 1 plus twice d by 3i d square by 3. We get this. If we taking 3 common, then this will be 1. We write in first term, twice d by 3 d square by 3. We write within bracket, this one. And this equal to imaginary part of e to the power ix. Taking this one outside and numerator, this will be 1 plus twice d by 3i d square by 3 whole to the power minus 1 x. We get this. So we expand binomially. This is imaginary part of e to the power ix by 3. If we expand binomially, 1 minus twice d by 3 I d square by 3 and dot dot dot, because our here given x means no need to expand more power, because we know 1 plus x whole to the power minus 1, 1 minus x plus x square minus x cube dot dot dot. Other powers no need to write, because our variable given x, if we differentiate only one time we get 1, next time will be 0, no need to write other. So this is imaginary part of e to the power ix by 3, multiplying this with this 1 2d by 3i x d square by 3x plus dot dot dot, and this is imaginary part of e to the power ix by 3, and here x multiplying x 2 by 3 I ddx of x is 1, this is 1, this is 0, we get this. So ultimately we get imaginary part of 1 by 3 e to the power ix means cos x plus I sin x, and this is x minus 2 by 3 I. We get this one. If we multiplying this 1 by 3, if we multiplying, then x and cos we get real. This and this, if we multiplying, I square is minus 1, we get plus 2 by 3 sin x, and this multiplying, we get imaginary x sin x. This and this multiplying, we get imaginary 2 by 3 cos x. We get this. Now this is real part, this one imaginary part. Our requirement imaginary part of, in this complex number, imaginary part means this is imaginary part. So this will be 1 by 3 and x sin x minus 2 by 3 cos x. If we taking LCM is 3, then we get 1 by 9 3x sin x minus 2 cos x. We get, this is our particular integral. Therefore general solution is y equal to CF plus PI. So this implies CF means A cos twice x, B sin twice x and pi is 1 by 9, 3x sin x minus 2 cos x, and this is our answer. Very easy solution, very nice. Consider solution. Another problem, and right hand side we get x cos x. Now solution, we write this is d square plus twice d plus 1 into y equal to x cos x. Then auxiliary equation m square plus twice m plus 1 equal to 0, and this implies m plus 1 whole square equal to 0 and m equal to minus 1 minus 1. Therefore, complementary function equal to c1 plus c2 x e to the power minus x 1x. Now particular integral. Particular integral, right hand side divided by d square plus twice d plus 1. This one particular integral. Now in this problem, here we get cos, algebraic and cos. We remove cos and we write in this way. This is d square plus twice d plus 1 x cos x plus I sin x. We write this, and here we write real part of r, only r p of real part of this means cos x, this imaginary part, cos x x, this real part. In short form we write this, but this is real part of, this is d square plus twice d plus 1 x e to the power ix. Ix means cos x plus I sin x. We write it this way, and this will be real part of e to the power ix taking outside, then d equal to putting d plus I whole square to d plus I plus 1. This is real part of ix x d square plus twice di plus I square twice d plus twice I plus 1. This one real part of x d square twice di minus 1, I square is minus 1, twice d plus twice I plus 1. This is real part of ix x by d square plus this 1 cancel, twice d 2 common and d also common, we get I plus 1 d plus twice I we get. From this 2 common and d common, I plus 1 twice I. This is real part of e to the power ix x by taking twice I common. This is 1 plus I plus 1 d twice I d square by twice I. We get this. So this will be real part of e to the power ix x by twice I, 1 plus 2 to cancel and 2 cancel, and I by I 1, 1 by I minus I d, and this is also, we write this is remains same twice I. we get this, and this one we write within bracket. So this will be real part of e to the power ix by twice I, and this one taking in numerator 1 plus 1 minus I into d plus d square by twice I whole to the power minus 1. But you know this formula, 1 plus x whole to the power minus 1, 1 minus x plus x square minus x cube plus dot dot dot. We know this. So this is real part of e to the power ix by twice I. We expand this 1 minus I d square plus twice I. Next will be whole square. No need to write other terms because our variable is x. X is here. If we differentiate one time, we get 1, next time will be 0. No need to write other terms. So this will be x. And this is real part of e to the power ix by twice I x 1 minus I d square by twice I into x dot dot dot. This is real part of e to the power ix by twice I x, and we differentiate this is 1, this will be 0, 1 minus I we get this. And real part of e to the power ix means cos x plus I sin x by twice I, and this is x minus 1 plus I. So 2 taking outside, 1 by 2 outside, cos by I, then minus I cos x, and I by I cancel sin x, and this is x minus 1 plus I. We get this one. Now multiplying this, real part of 1 by 2 remains same. If we multiplying, then this and this we get real. X minus 1 into sin x we get real. I square minus 1, this is plus 1 plus cos x. This real. And imaginary I common, I and sin we get imaginary sin x. This and this we get imaginary minus x minus 1 cos x. We get this one. So our requirement real part. So this is real, this one imaginary. So what we get, real part of this means 1 by 2 x minus 1 sin x plus cos x. We get, this is our real part, x minus 1 sin x into sin x plus cos x. This is the real part of this, and if we multiplying this 1 by 2 x sin x minus sin x plus 1 by 2 cos x minus sin x, we get this one. So general solution is y equal to cf plus pi. Y equal to cf means this one, c1 plus c2x e to the power minus x, and pi means 1 by 2x sin x plus 1 by 2 cos x minus sin x, and this is our answer. Very easy solution, very interesting also. So this is the complete solution of the given problem. So dear students, I hope you are all enjoying. If you are enjoying with this problem, then please share this video to your friends, other engineering friends, and this is most important problem for engineering branches and BSc Maths major also. Thank you.